Okay, so today we're going to look at example number 3 in section 6.3. It is on graphing horizontal and vertical lines, and we're also going to review some of the stuff we looked at yesterday. Okay, so first we'll look at example 3 here. We have a t-table with some information. We have time in seconds, and we have distance in meters. And the first thing I noticed that's kind of different, and we looked at this a little bit yesterday, distance is always 6. So even though time varies, distance does not. It's always 6. So they ask us to draw a graph to represent this data. So first thing we want to do, you can use a ruler. Do this with me. Create some axes, arrows on the end to show the lines continue. And we remember that X is always the first column and Y values are always in the second column. So this tells me that time, okay, is going to go down on the X axis. In this case, we're going to call it T, and time is in seconds. Distance will be on our Y axis. Okay, it's in meters, and our variable is D. Time jumps by 30-second intervals, so we may want to also jump by 30-second intervals, 30, 60, 90. I'm going to skip a box between because we seemingly have space to do so. Okay, and distance is always 6. Now that doesn't mean we just put 6 on the axes. You still want to count up as a normal axis, so I might just count by 1s. Okay. It never hurts to extend a little bit beyond the value you need. And then we're going to plot the points. So we have 0 on the time axis is 6. Distance, 30 seconds is also 6. 60 seconds, 6. And so on. Pretty easy to graph. Okay, so what we notice here is we have a line, okay, that does not go on a normal slant like we would typically see with most of our equations. And what you're going to notice in this last piece of section 6.3 is when one of the coordinates is always the same number, you are either going to get a horizontal line or a vertical line. Okay, if it's the y value that remains constant, it will be a horizontal line. This is a horizontal line. Okay, and we can also extend it in this direction. Yeah, so something a little bit different for you. Write the equation. Explain how you know the graph represents the equation. Now we've come up with a little method for writing equations from t-tables. And you can use that method here again if you would like. So our method would be, we always start with the variable in the y box, so d equals. We see what we're increasing by. It is 0. On this side, we're increasing by 30. 0 divided by 30 is 0. T. Okay, and then we always talked about finding our 0 value, which is plus 6. So our equation would look like that in this situation. You're probably thinking it right now. We never leave a 0t. So this term actually cancels out. 0 multiplied by anything is 0. So that term goes away. So our equation really is d equals 6. Okay, that is the equation I want you to come up with here. And this old method, I wouldn't really use that myself when I'm looking at this table. The equation for this table is d is always 6. So d equals 6. I wouldn't really need to use this old method here. So d equals 6 is the equation. Explain how you know the graph represents the equation. I'm not too concerned with that. We've discussed that kind of in length there. Okay, let's look at table 2 here. So this time you'll notice that the x coordinate is the coordinate that is remaining constant. So you can kind of guess, instead of a horizontal line, maybe we might get a different special line. Okay, so we're going to graph this and find out. So create my axes. Okay, sketch this with me. The distance is in meters on the x-axis. Height is also in meters on the y-axis. Our distance is always 1.5, so again, you're going to still create a normal scale. Maybe you want to jump by ones or 1.5. I might jump by 1, but I'm going to spread it out. So maybe you could think of jumping by halves, whatever you'd like to think there. And then my heights jump by halves, so I will also jump by half. I'm going to do 1, 2, 3, 4, 5. Okay, and then we'll plot our points. 1.5 on the x is 2.5. On the y, 1.5 is 3. 1.5 is 3.5. 1.5 is 4. And 4.5. There's your line. Guess what kind of line it is this time? Okay, you guessed it. It's a vertical line because x is always the same. Okay, write the equation. Okay, when one of your variables remains constant, your equation is simply this equals that. So x equals 1.5. Okay, that's all I need to write. Okay, that is great. So just to summarize things here, I think in your handout, yes, you need to fill in these lines here. So if all x values are the same, the graph will be what kind of line? Okay, it's a vertical. You need to know that. That is basically a test question right here. Okay, if all x values are the same, think about it. If x is always 0.9, okay, I'm going to get a line that runs vertically. And then if all y values are the same, if y is always 3, I'm going to get a horizontal line. So the equation for this graph here would be x equals 1.5. X is always 1.5. And the equation for this graph would be y is always 6. Or in this case, it's d. So d equals 6. Okay, we're going to look at another example here. They want you to graph this equation, y equals 2x plus 3. Graph it. Where do we start? We talked about this yesterday. Okay, you need a t-table to make a graph. So first thing we're going to do is sketch a little t-table. Okay, y equals 2x plus 3 is my equation. Y equals 2x plus 3. I'm going to put x and y. You pick the x's. You have to pick these values. We discussed how typically you would pick a few negative numbers and a few positive numbers. So most people stick to these same numbers every time they have to pick. -2, -1, 0, 1, and 2. Okay, once you pick your x's, you need to substitute those x's into your equation to find your y. So if I was showing my work, okay, I'm going to substitute instead of x, -2. I'm going to solve that little expression. 2 multiplied by -2 is -4, plus 3 is -1. Substitute all of your x values. You can fill them all out first if you want, just like this. And then solve all of those expressions. Pause the video if you like. Take a minute. Okay, and solve all of these. I'm just doing them in my head, and when you're finished, you should check. Okay, they should increase by the same number each time just to make sure your math is correct. Okay, now we have 5 points we can plot. Okay, there's your first point, -2 and -1. These are your points to plot on the graph. If you want to write them out like little ordered pairs, you can. Okay, these are the points I'm going to graph. So I need to get up to +7. I'm going to create my Cartesian plane and label it. Your numbers should be labeled right on the lines. Okay, and then we can plot these points. -2 on the x, y to the sky, -2 and -1. First point, -1 and 1, 0, 3, 1, 5, 2, and 7. 7 goes off my graph a little bit. Okay, once you have your 5 points drawn, you can connect the dots with a line, and you should put arrows on the end, okay, showing that it continues in both directions. There you have it, y equals 2x plus 3. Okay, yesterday we talked about too, just a little extra piece here. This plus or minus piece at the end, okay, is called your y-intercept. Y-intercept. That is where the line crosses the y-axis. So right here at 3, okay, crosses at 3. It's a quick way to match up graphs and equations like we did yesterday. Okay, then we're asked to graph y equals 5. I'm going to do it on a new slide just so it looks looks a little bit better. Okay, y equals 5, so we need another teacher. Okay, this is one of our new types of equations. There is only one variable in the equation. You still make an xy t-chart, but y is always 5. Y is always 5. Okay, that's what the equation says. You get to pick your x's. You might want to do the typical 5 numbers we like to pick, and then we graph them. Okay, so quick Cartesian plane. Label it. You can pause the video if you need some time. And then we label these points. -2 on the x-axis is right here, and a 5. -1 and 5, 0 and 5, 1 and 5, and 2 and 5. Okay, there we've got a line. It is what kind of line? Okay, when x values, when y values are constant. Okay, y was always 5. You get a horizontal line. That's what we're seeing here. Okay, that is great. There's only one other little piece here in this section that I want to look at. And this is question 10 out of your book. And in this type of question, they actually give you the graph, which is kind of nice. You don't have to graph, it's there. And they ask you, what is the equation? Okay, and if you remember back to the start of this chapter, we can only build an equation easily from a table of values. Now there's other ways to do it, and next year they're going to show you ways to pick it all off the graph, but for our purposes this year, we want to make a t-table. So we have x and y here, and what you have to do is you have to pick the points off of the graph. And then once you have the points written in, you can come up with your equation. Now, the only advice I'm going to offer you is pick at least 3 points and pick them left to right. So if I'm going to pick, maybe I'm going to pick off these 3 points. Write them in left to right. So the coordinates of this point are -2 and 8. Okay, this was -2 and 8. Here we have -1 and 4. And we have 0, 0. Okay, and you can do more than that too if you would like. But you need at least 3 points, and then you should be able to come up with your equation with our little method that we use. So y equals, see what you're increasing by, we're decreasing by. Here we're decreasing by 4. On this side we're adding 1. Divide them, so -4 divided by 1 is -4. X. And then your 0 value. 0 value is 0, so it's +0. So that is it for our equation. So our equation here is y equals -4 times x. Okay, we'll look at B. We'll look at B. We got a new equation here. A new graph, sorry, new equation, yep. We're going to make a t-chart. We still have X and Y. You have to pick 3 points at least, and you have to pick them left this side to this side. So I'm going to pick, and it's good to always pick around the 0 because that helps you with your 0 value. So I'm going to pick 1, 2, 3. Okay, you got to start in the left though. I can't start over here. So I'm going to start on this side. I have, now that point is very hard to read. It's -1 on the x-axis, but I do not know what it is on the y. So here, I'm going to change my story. Maybe I'm going to pick 1. I'm going to skip that one because it looks too confusing. 2, and skip 1. Let's try this and see if it works. I'm not even sure. -2 and -3. We've got 0 and 2. And I've got 2 and 7. Okay, we've got y equals, what in the world's happening on this side? 5, 2. 5 divided by 2 is 2.5 x, and my 0 value is a +2. Okay, that's where that came from. That is a tough equation. Y equals 2.5x +2. Okay, so you are allowed to pick points. You are allowed to skip as long as you're consistent. Okay, skip. You skip a point, you skip another point. You can do that to get your equation. Okay, if you'd like to pause the video and try number 11 yourselves. Okay, and then I will go over it. All right, so number 11 wants a linear equation from the graph. So we have to pick some points off in order. I might try to pick these 3 points. 3 is the bare minimum. Remember, start on the left, so this point has to get written down first. So I have -1 and 1 point, -1.5. I have 0 and -1, and I have 1 and -0.5. Okay, and go to build your equation. Y equals, what are we doing here? I'm adding 0.5 each time. Okay, this side we're adding 1. 0.5 divided by 1 is 0.5 x. And then your 0 value is -1. Okay, half x minus 1. You could write that like this. Okay, that's the same thing, 1/2 x, okay, minus 1. Okay, and B, now B is kind of a nice one because it is a vertical line. If you want to pick points off, you can. X is 4 and Y is 3. X is 4 and Y is 2. X is 4 and Y is 1, etc., etc. What you're noticing is X is always 4. Okay, your equation is X equals 4. Okay, I think that's probably pretty good there. Number 12 here, just wanted you to graph this table of values, which you could. But they also want you to create an equation, and this is good practice. Can you write the equation for this table? Can you write the equation? So I might do that quickly here. Y equals, we're going up by 3, going up by 1, so 3x. What's your 0 value? -1. So that is your equation. And then to graph that, just for time, I don't think I will here, but you would create a Cartesian plane, label your x-axis and y, and then plot those points. Okay. And then just really quickly, again, I'm not going to graph this one, but here we have f and z. You can think of it like x and y. Okay, z's always -3, so your equation is simple. Z equals -3. And if you're going to graph that, y is always -3, so it's going to be a horizontal line. Okay, for that one. Okay, that's it. You're going to have some practice to do. Okay, good luck, work hard, and ask questions.